we go. This is the Unit 4 portion of our trig view. Unit 4 was all about graphing trig functions. And if you remember, if you think about a trig function, I'm just going to say like y equals or f of x equals, doesn't really matter. The generic formula was a times, I'm just going to use a sign, right? A times the sine of, then we had bx plus c, and then plus d, right? And I guess I should really say plus or minus on both of those, right? Because the plus, whether it goes up or down or what have you. Um, these could be cosines, they could be tangents, right? It's going to follow the same kind of idea here. Um, a, the a value was the amplitude, right? And that kind of determined how tall our graph was. B is our, what's that? That is the period. So B kind of determined how short or how long one cycle of these functions was. C was our phase shift. Right, so that basically that pushed the wave to the left or to the right, just kind of depending on the value. And then D, the last one, D, was our, we call this our vertical shift. This one pushed the entire graph up or down along the y-axis. And the D value, the vertical shift, that's kind of the easiest one to figure out, in my opinion. So before we even start graphing these things, let's just kind of recall what the sine and the cosines looked like. So with the sine wave, with something like this. So if I make a graph, it started right at the origin and it went up, and then it kind of curls around, it comes back down, passes back through the x-axis, and then bottoms out and then ends back at the x-axis. All right, so we always said when you graph these things, look for 5 important parts. All right, so the 5 important characteristics of the sine function, obviously, where does it start and where does it end? All right, find that middle point, and then find that maximum, and then find the minimum. So if you want to think about the sine function, it had a period of 2 pi. So from the time it starts and the time it ends, that is 2 pi, right? And then it's just a matter of chopping this thing up into different pieces. So we have right in the very middle, it hits pi. So, halfway through, it kind of crosses back through that x-axis. And then we have the other two. It maxes out halfway between 0 and pi. So that's just going to be pi over 2. And then it bottoms out between pi and 2 pi, and that is 3 pi over 2. All right, so we split it up into those different pieces. All right, so we have 5 important parts that we need to graph. Right, on your generic sine function, it maxes out at 1, and it bottoms out at -1. So the a value on these things is going to determine maximum and the minimum spots. The d value determines, we call this our midline. All right, so that's kind of a good place to start. That midline gets pushed up and down. Then we have our minimums and we have our maximums here. All right, so that's what our sine function looked like. The cosine function, it looked very similar. All right, it was another wave. These things, they're called cyclical because they look like cycles. This one, it starts up top, right? And then it goes down, it kind of curls down, and it still has the same wave shape. And then it comes back up and it ends there. So our 5 important parts, where it starts and where it ends. Now halfway through is where this one bottoms out. And then the 2 other pieces where it crosses the x-axis. All right, so just like sine, the cosine has a little period of 2 pi. All right, that halfway point is at pi. and then kind of the two pieces there. At pi over 2 is where it crosses the x-axis, sometimes we call that the 0, and then 3 pi over 2, that's the other 0 on this thing. The midline is also at 0, it's that x-axis. The maximum is at 1, and the minimum is at 1. All right, so that's what these two formulas look like as graphs, as waves. A lot of times we call these waves because they just, they look like waves in the ocean or something. So the whole idea here is, how do the numbers that we plug into the equation affect the shape of these graphs? How tall are they? How short do they get? That sort of thing. So we're going to graph these and see what happens. All right, so they're asking us to identify the amplitude, vertical shift period, phase shift, domain, and range. All right, so we'll talk about the domain and range after we graph this thing. All right, so the first thing I notice here is we have a vertical shift of 1. All right, so we're going to push the entire thing up to 1. All right, so if I think about that midline, all right, I'm not going to put it on the x-axis. I'm going to put it, one space above. Now this graph, it doesn't have a scale on it. So, if you want to call that one space up, great, then you do that. We just need to kind of make sure we are consistent, make sure your spacing is good. All right, now the next thing I notice is the amplitude. The amplitude here is 3. All right, so what that means is we're going to max out 3 spaces above this midline. So again, just kind of make sure your spacing is good. All right, so this is going to be our maximum height that our sine function gets. And then since the amplitude is 3, it's 3 above the midline, and it's 3 below the midline. Right, so the entire wave that we draw should be between, all right, those two black dotted lines that I have drawn. All right, so we need to figure out all of the other stuff here. If we think about the sine function, it starts at 0 and it goes to 2 pi. All right, but we said that the b value kind of determines the period of this thing. So to figure out the period on any function, the period is equal to 2 pi divided by that b value. All right, well, the b value here is 5. Here, I'm just going to write all this stuff down. A equals 3, b equals 5, c equals that fraction, 2 pi over 3, and then d equals 1. Right? So the period, the length of one cycle of this thing is 2 pi over 5. All right. So if we just kind of think about that, we can start, I can identify the 5 kind of important pieces here. If it starts at 0 and it ends at 2 pi over 5, let's identify those halfway points. So 2 pi over 5, if we cut that in half, that gives us 1 pi over 5. And if we cut that in half, it's pi over 10. Halfway between pi over 5 and 2 pi over 5 is 3 pi over 10. If we wanted to make life a little bit easier, we could put all of these as common denominators, right? So instead of calling this pi over 5, I'm going to call it 2 pi over 10. Right? And the last one, instead of calling it 2 pi over 5, we can call it 4 pi over 10, right? And for me personally, this makes it look easier because, look, you're going 0, 1, 2, 3, 4 on the top, right? And then all your denominators are the same. Right? So those are kind of the 5 important parts. But we do have that phase shift to take into consideration. All right, if we didn't have any phase shift, those would be the values on our x-axis. But how do we determine the phase shift? The phase shift is negative b over C. No, it's not. I got that backwards. It's negative C over B. So what is my C value? I forgot. C is 2 pi over 3. And B is, what is B? B is 5, right? So this equals negative 2 pi over 3 all over 5, which gives us, oh boy, what does that give us? That's negative 2 pi over 15, right? So what that means is we have to subtract 2 pi over 15 from all of these values here, right? So unfortunately, we have a lot of fractions here, so this might get a little messy, but we're just going to have to make do. And so this is where if you want to pull out your calculator, you can. Every single one of those black values that I have, subtract 2 pi over 15 from them, and that is going to be our x values when we graph this thing. So the first one is negative 2 pi over 15. The second one, think about, all right, well, pi over 10 minus 2 pi over 15. Let's just do that. Make a fraction, alpha y equals, I'm going to call it 1 over 10. I'm going to ignore the pi for now. I'm going to put that back in at the end, right? Because the calculator doesn't deal with pi's very well. So minus, make another fraction, right? That's going to be 2 over 15. What is that going to give us? That's negative 1/30th. So this is negative pi over 30. All right. And then we just kind of do this again. All right. So 2 pi, I'm just going to copy and paste this one down. We have 2 pi over 10. Call that a 2. And then we need to subtract the 2 pi minus 15 again. That gives us positive 1/15. So pi over 15, and so on and so forth. So I'll just do it one more time, because you might start seeing a pattern when you do these things. So we have 3 pi over 10 minus 2 pi over 15. That's 1/6. Why is that 1/6? Pi over 6. And then the last one, 4 pi over 10. Copy this down one more time. This gives us 4 pi over 15, right? So if you look at those numbers, they do look kind of messy, but if you want to unreduce these fractions and make them all look like common denominators, then you'll see that they actually do follow a pattern, right? This next one, this is really 4 pi, negative 4 pi over 30. This one's negative 1 pi over 30. This one is positive 1 pi over 30. This next one, if you multiply them both by 5, you get 5 pi over 30. And then the last one gives us 8 pi over 30. Right, so that's what they would look like unreduced. Remember, your calculator is always going to reduce things for you. But if you look at all of these, they follow that same pattern. You're adding 3 to them each time. Right, so we're okay. Nope. See, this should have been 2 pi over 30. Right, you're adding 3 pi over 30 every single time to these things. All right, so these are going to be your x values here. Right, so we know that there are 2 in the negative direction, and there's 3 on the positive side. So I'm just going to fill those in. So we have negative 2 pi over 15. We have negative pi over 30. Positive pi over 30. We have, see, I made a mistake. That needs to be pi over 15. This is pi over 6. And the last one is 4 pi over 15. The very last thing is to remember, hey, this is a sine. So sine starts at the midline. Then the very next one, it hits its maximum, goes back to the midline, it bottoms out, and then hits the midline for a final time. So just kind of make that trace as best you can. There you have it. That's what it looks like. Okay. So we can figure out the next. That's how we graph it. Now we can just kind of fill in all these blanks. The amplitude here, that's just the A value. That's just 3. The vertical shift went up 1, so you could write up 1. You could say plus 1, however you want to do that. Or you just put 1. The period, we found that earlier, was 2 pi over b, so that's 2 pi over 5. And then the phase shift, we also found that was negative 2 pi over 15. Right? Now, the domain, that's the easiest question in this entire chapter. The domain of the sine function and the cosine function is all real numbers, or if you want to say, you could say negative infinity to positive infinity. Now, the range is how high does this graph go? How low does this graph go? Well, look at those lines we have here. 1, 2, 3, 4. It goes and maxes out at 4, and it bottoms out at negative 3. So the range goes from negative 3 to 4. But remember, on the range on these things, we need to have brackets because it actually hits those values. It actually touches negative 3, and it actually touches positive 4. All right. So there we have it. That's how we graph these things. These videos are getting long, so I'm going to end it right there on this one. So we'll see you guys in the next one.